Hello, hello, Kim. I don't know if you're able to hear me. Oh, okay, okay, good,
I hear
good.
you very well.
So
Can you hear me?
let's start at 4.
I've lost you, Steve.
All right, that is okay. 4:10, 4:10 it is.
Okay. Well, thank you very much. I think it's 4:10. We are going to start now. First of all, I'd like to welcome you all to this webinar. We're going to walk through the product design. And with us is Steve Kinaro. He's a product designer at, what do you call it? It's a little difficult to pronounce that name. I'll call upon you, Steve. You first introduce yourself and tell us what you do at GW Instant, and then you can start. Can you hear me, Steve? Steve, can you hear me?
All right. I think we have quorum, so we can just kick this off.
Yeah.
I
I'd
don't know
first
if
like to.
I'm audible.
Yeah, I can hear you. I can hear you very well.
Hello.
Hello, can you hear me, Steve? Hello, can you hear me? Steve, can you hear me? I get a response from Kevin, both of us, but same page.
Hello. All right. Seems not to hear me. Okay. I can see in the chat section that you can be able to hear me, but I'm not getting audio from you. I don't know. Just trying to change the settings for this. Okay. Hello.
Can you hear me now?
Yes. Finally. Now yes. Now I've shared my screen. Don't know if you're able to see it.
Yeah, I can see your screen. I can hear you very
All
well as well.
right. All right. Thank you. So we can start it off.
Yeah. I would like first like you introduce yourself and tell us what you do at GW Winston, and then we can start.
Definitely. So my name is Steve Ogeto Kinaro. So I'm for quite a while now. My background is biomedical engineering. Currently, I'm working for WJETSEN Energy Solution. It's a renewable energy company. And once we get through what I'm about to present to you, you'll be able to know a lot more about what I do and where I am currently. Yes. So, all right. So let's keep on to the PowerPoint. So today I'll be presenting about product development and essentially with a focus on product design and what product design can really do for you. I saw that in the brief that you had specified that product design is capable of bringing your ideas to life, and not just that, but also creating an impact with those ideas and actually pushing them into market, such kinds of things. So product design is essentially a part of product development, whereby you develop the concepts and then you visualize the ideas. Essentially, you visualize the ideas, and this really contributes to saving costs. It really contributes to seeing the end products, prevents you from making very many changes in the final products, because essentially product design helps you to see and visualize the idea, and it also helps the end user to also visualize it before now you actuate it. It's a concept that has been developed primarily to save on costs, but also to ensure that you get things done right from the very first go. So just to move on next. Okay, so now that's product design. Product development now is a process that starts with generating the ideas and all the way to giving the ideas out to market and implementing them. And essentially, what I usually do during my workday is trying to find ideas and trying to find challenges that are affecting our end users, speaking to them. I don't know, probably if anyone has heard of design thinking, essentially going and listening to the end user, asking the right questions and knowing which challenges are facing the end users, and then from there generating ideas that can actually create an impact to the end users, and then now starting the development process. So essentially, that's what I do. So W Jetson is a renewable energy company that's not just focused on giving solar energy and storage or batteries. It's also focused on creating an impact in people's lives and changing life, and innovating and existing in the market for a very long period of time. So for instance, we've been in market for the past 145 years, and we've been in market for all these years because of reiterative prototyping and innovating and advancing from one section to another different section. For instance, from ships, manufacturing of ships, all the way to now development and all the way to renewable energy. So essentially, it's a company that evolves to essentially create an impact into society. So just as you can see, these are some of the projects that we've done. We've around Africa, started with Kenya and now evolving throughout Africa, creating now sustainable green energy. And we have been evolving, not just trying to put it in layman terms, not just in commercial, but also in hospitals, also in residentials, also in people who need pumps, agri sector. So we've been evolving into different sectors for different applications. And one of the key drivers of WJS is that we are committed to the UN SDGs and creating an impact with those. So one of the things that has kept us in market essentially for this long period of time is that we have in-house a product development team. So the product development team. Currently, there are 4 of us, and our main focus is to develop solutions through IoT and channel them out to now the different clienteles that WGS is dealing with, and essentially solve the individual challenges that they have. So currently, if you can see, we have somebody focused on the IoT side, remote monitoring and cloud integration. We have somebody focused on embedded systems, somebody focused on AI and analytics and cloud integration. Then we have overall a product development manager who oversees the entire process. I'm focused in now the design process, the entire design process of product from start all the way to end, and more into the mechanical side. So one of the critical things that I'd like you to understand is that for you essentially to develop a product, you need to have multiple skills. You can't learn all skills, but you can have a team that you can work with and rely upon, so that you can focus on essentially one part and become a master of it. So that is how I've always done throughout my design projects all the way to right now. So one of the key challenges that we've been tasked with as product development is essentially creating impact on a large scale. So this is through finding solutions, ideas, going to the end users, finding ideas, and trying to implement solutions for those ideas. So one of the things, if you can see the screen, one of the things that what you're seeing on the screen is a mini grid, and one of the challenges is solving is to essentially make villages more smart and empower villagers to have the capabilities to create, essentially to empower them to have resources in the agri sector and learn about how to essentially improve their lifestyles and normal styles of living. So what you're seeing on the screen is what we call in design a conceptual model, and I'll take you through how you can be able to develop such kinds of things. So this is just developed from a concept brief given from uh, a client, and then now spoken to the end users, and then now trying to find ideas on how to put together something that they can visualize, and then now ideate and prototype around and brainstorm on more ideas, and then now essentially result in the creation of something like a mini grid for villages and such. So I'll take you through some of the softwares which can really help you in case you are interested in product design. So so now let's talk about the product development process. So today, what I essentially want to do for you is to give you my experiences in terms of how I've navigated through the product design field, how I started all the way to what I know now. Maybe touch on some of the mistakes that I made, and essentially give you the leeway to get interested, so I don't want this to be too technical, but I want to give you the platform where you can have that stepping stone to jump into design if you're driven towards design. So design or product development usually starts with a very first stage whereby you do a use case analysis. So right here, there are some images of end user clients, us communicating to the end user client, flower farms, daily for into the end users and talking to them essentially to try and understand which challenges they are solving, which challenges they are encountering, and which we can be able to solve. So essentially giving them an additional advantage and helping them, walking the steps together with them. So right here, this is the very first stage whereby you can do online surveys, you can do questionnaires, you can print them, go to the end users, talk to them. You can know offhand which kind of questions you're trying to, which kind of questions you have for the end user. For instance, pick the flower farm. You'd want to know about their process, how they usually do uh, the kind of things. Maybe now focus into a challenge that you have prior information on, or a challenge that they've presented to you. Essentially, design thinking process. Try to understand what the user is saying and what the user isn't saying, and try to see the challenges that the user is facing. So one of the things about design is that design is driven by the end user. It's very important that you speak to the end user before you start the design, after you finish the design, when you're doing improvements on the design. So you have to keep on talking to the end user to understand really the challenges that they are facing. And this is also very critical in product development. So after you've done a use case analysis, you can now start developing a Word document. Essentially, this is um, design considerations, the idea. You can start now jointing down maybe a paragraph of the problem statement that the user is facing. So that is now developing the design brief. Or you can give the user to send you a design brief if they are technical in terms of understanding what that is. But essentially, it's best to go and interact with the end user and understand what kinds of challenges they are facing. So that's the first stage. The second stage is now you have the idea, you have the challenge, and then now you sit down with the team, brainstorm, do essentially a concept, write down a concept, and then now after you write down a concept, generate ideas from different concepts. So for instance, saying on the flower industry, saying that somebody is telling you that they are not able to control the packaging section, to essentially do the packaging section of the flowers. So they're not able to automate, and they need you to automate that process, or they want you to monitor, or they have a problem with their air conditioners, and you realize probably they need to monitor their temperatures. Or so essentially you develop now ideas or potential solutions. You can say right here in concept development, you can give what we call moonshot ideas. You can say, if they want to monitor temperature, why don't we uh, bring a person who's really good in knowing the weather to just stay there and try. So you start now to try and feel the temperature. Why don't we maybe use an infrared gun, the ones used for COVID-19, to try and check the temperatures. And then you can come out with very moonshot ideas, unrealistic ideas, and then sit down with the team, brainstorm, and then now keep on uh, removing ideas and then seeing which idea really fits. So in the brainstorming session, you can have maybe 3 sessions. First session, you have it with your development team. Then now you go on and have it with the client, present the potential solutions which you've agreed on, and then now essentially go back to now a concept development. So after you've gotten ideas, so in the concept development, you can now start visualizing the ideas. So, for instance, one of the challenges that I got when I started working in WG is in the mini grid projects or creating an impact for villages. One of the challenges that they have is that they cannot be able to essentially grids, and also they do not have the means to just jump and get all this technology, IoT, and all that. So that was a big challenge. How do we empower them to have that means? So we decided as a company to volunteer and uh, essentially do a concept related on what the villagers are doing. So right here we focused on poultry. We try to understand which challenges are they encountering, because the the setup was Zanzibar, so it's a poultry economic zone. So you realize that the farmers right there were encountering problems with getting feed for their chicks, incubating their chicks, and such kinds of things. And they were also situated in really remote areas whereby you find grid will not be there, so you'd find even doing incubators would be very hard. So essentially, the first thing that I did is try to understand the problem, get the challenges, and then now do a concept, a visual concept that they can be able to understand. So one of the softwares that really helped me in quickly putting this abstract idea into something that the end users can see is uh, it's SketchUp. So I'll get into the softwares, but SketchUp really helped me to quickly visualize what this the idea or the challenge that they were facing. So um, essentially, what you're seeing right here is now the concept. So this is the concept that we ended up developing, and then now back and forth with the client to discuss on what we can be able to do, what we can't do, looking at standards and regulation. So essentially, a concept is something that you can visualize to a client, and then they can see that this is how their end product is going to look like, and it's usually guided by the end user themselves. So a concept development cannot be, you can even do just a paper concept design. You can just script it down. You can do maybe a PowerPoint and present it to the user. It doesn't have to be a drawing and render, but drawing and renders are usually good. So after now you do the concept design, then now you jump, after you've talked with the client, you see that the concept can work. Essentially, you now jump into now the heavy work. You jump into a design concept. So a design concept is essentially a bit heavier, and it's usually paired with proof of concept. So this is where now you bring in the electronics. So you don't want to be programming before you know that the client is actually facing a challenge. So essentially, you can get mini kit boards like Arduinos. You can get STM boards, and then now try to develop now a concept out of what a proof of concept idea that will prove that what you're going to develop in the end is something that's going to work and it's something that's doable. You can do even a code, try to see, you can do a software prototype, you can do wireframe sketch to just see how everything is going to work. So that is a proof of concept design. So it's not an end, it's not an end user product, but it's essentially something that proves that technically that the project it's technically feasible. So after you do that, now you do now you do what you're seeing on the screen now is the proof of concept. This is for a monitoring system. So temperatures, this goes hand in hand with the poultry solution, because you realize for chicks, you need to incubate them, but you also need to know the temperatures. You also need to save on energy because you want to ensure that the concept is sustainable because it's in a really remote area. So you don't want them to be using too much energy. You want to turn off the incubator when the temperatures are right and such kinds of things. So have control within the concept. So essentially, this is now the concept design to be able to just observe that you can also remotely monitor this and control that. So the IoT section. So after you do a POC, you now develop testing protocols. So testing protocols, you can say just something simple like this. I can buy maybe the infrared lamps, do maybe buy a big box, put them inside, see if my proof of concept is working. You can 3D print your model, what you've designed, and essentially see if everything is going to be right. You can do simulations. If you're good with SolidWorks, you can do forces, you can do weights. You can know that essentially if it's something small, it's going to weigh this amount of size. So if somebody is going to carry it, it's going to weigh. So you do essentially you create a testing protocol whereby you say, for instance, I need to see if these temperatures can be achieved, and this is the scenario. I'll set up this as this box is going to represent this room, and essentially just do now something that imitates the end user scenario. So after you've done that, you've seen that it's able to work. You've done the proof of concept testing. You jump into the MVP. So MVP is now the minimum viable product for the user. A good thing that you realize about the end user is that they usually give you a lot of challenges to work with, but a good thing that you also need to know is that you need to be able to filter these challenges out. You need to know which is the most critical challenge that they are facing, because when you're developing a product, you don't want to develop everything at once. That won't work. Usually go for less is more. So usually go for the minimum challenges and solve them with the product that you're giving them. And then now from there, after you've solved the most critical challenges, you now essentially develop now the product. So give them to the end user, and then now do what we call a pilot. So a pilot, you give it to the end user, see how it performs, and then essentially after you've seen that, get back the results, and then now keep on improving. So that's a pilot. You also do product testing within the pilot. So a pilot, you can agree with the end user. Maybe you can subsidize the costs, or you can agree to do it for free, and then try to see what kinds of challenges will be seen with the product that you're developing, and then now get back the results, and then from there now start developing now essentially documentation for that. One important thing that you also need to know is that for documentation, you need to do it all through the entire process. So when you're starting, just ensure that you record what you're always doing within the project that you're doing. So it's usually very important. Let's say you've gotten the challenge, do a paragraph about that challenge that the end user is facing. If you've spoken to the end user after meeting, do maybe meeting minutes so that you have documentation of the entire process, how it went, and this really helps when you're doing now when you have the product. Now you're developing now data sheets and product specifications, and you now need to give it to sales. You need to develop maybe flyers, maybe documentation. So it really helps when you're generating now information from that. So, and also the test results and everything, just document everything and then have them in one folder. So after you've done that, you have the product, it's working, you have it tested, you have the documentation, you have for sales, you have their flyers, you have their marketing materials. You now you have you now develop a training procedure for now the product. Say you've developed the poultry facility. You've developed the poultry facility, everything. So it's essentially now the entire solution. So you can try to do a user guide, do a user manual, and then now do a PowerPoint on training, because the next phase is now doing a product launch. So in product launch, you have to now first of all, convince sales, or your team that is really good in convincing customers to sell this out, or your team who's good with the end users. Essentially involves the people who can create a business development case, people who are good in finance, to advise around this process. So right there, talk with them back and forth and try to see if this solution can sell. And then now give them now the training on the solution. And then after you do that, now do a product launch where you invite now the different people. You invite the clients who you develop the solution together with, and then now you give them a breakdown on what you've developed and what you're thinking of. Essentially just get their reviews, what they're thinking, and essentially on how you can improve the product. So it's usually a back and forth, but one of the key things that you realize is that the client is usually at the center of everything. And throughout the stages, design is very critical in helping you save cost. And this is because you're actually able to see before you now start developing the actual MVP, whereby even the proof of concept, these stages, they are very critical. In case you are in innovation, they're very critical. Don't jump into made some mistakes just jumping into a product development without going through these stages. The challenges you're going to encounter if you skip these stages are many, and the costs are going to be high. But if you follow the steps, you find like you saved a lot of costs on working through with the client. You saved a lot of costs on doing concepts, and essentially you yes, you get the product done the right way the first time. So this is one of the products that we developed. Ice machine, one of the products that we launched. So this is essentially a flyer to just call out people to come in, and then now we do now a product launch. So from doing now the product launch, you now hand over to sales, but you work together with them so that they can understand the product very well. And then now you move on to the next project. So due to time, I'll just now take you through how I get things done and some of the essentially some of the things that I've designed and my progress from when I started. So these are what you're seeing on the screen are some of our products, what we've been able to uh, one of the things that we've been able to develop is the solar poultry solution facility. I'll be able to show you how you do that. So these essentially are some of the products that we provide. So just to jump into the poultry solution and probably show you how you can quickly come up with a concept without spending too much time. I know we have when you're getting into product development, you're going to be tossed into a lot of softwares. You're going to be told do Inventor, do SketchUp, do SolidWorks, Anis, do all those kinds of softwares. But one of the things that I've learned is that it's usually good to let the challenge that you're currently facing drive you towards the software that will help you solve it. So the first time I got into WGS, the first project was the poultry solution. I got a design brief. They'd already done the first stages, got the design brief. They had in mind what they wanted to probably actuate, but they were not pretty sure about this. So essentially what this meant is that I'd be doing a model, I'd be doing renders for them to quickly make changes, and will be essentially brainstorming around the model and making changes really quickly. So this gave me a challenge whereby I said, okay, I'm good in SolidWorks, a bit on Inventor, good in AutoCAD, but I need to really do this quickly. If I do this with parametric softwares which you need to use like SolidWorks, you need to do dimensions, you're going to get all those errors and it's going to be really stressful. So I need to instantly design this. So I need to do it in free form. So essentially what I did is went out, researched and found out SketchUp, open source. You can be able to quickly do a concept out of this, and decided to dive into the software. Did 1 week just learning on the software, and then now started doing the model. So, so what you're seeing right here, this is SketchUp. Let me just open SketchUp just in a bit. So this is SketchUp. SketchUp it's a free-form software, usually very quick. If you're told maybe you're doing product development and then you're told like we need to do a 3D model within 3 days. We need to do a 3D model within 3 days and see the actual product. Their SketchUp is usually you go with free form softwares. This could be SketchUp. It could be it's in a bit. There are usually two softwares which are really good in this SketchUp. It could be Blender and it could be Fusion 360. So they are really good at creating models really quickly, but not in detailing in terms of dimension. So if somebody wants to see the concept and keep on iterating around the concept, I'd usually advise maybe going around with this. Yes, with SketchUp or Fusion 360. So in SketchUp, all right. So what you're seeing on the screen is it's a mini grid powered village. So just waiting for it to render. Let me just focus on the poultry facility. Yes. All right. SKP. Okay, so this is a poultry facility. So the idea was to essentially provide the villagers with a platform that can bring them together. You have people who are rearing chicks. You have people who have um, full grown chicken. You have people who have poultries, who have poultry milling machines or feed processing machines, and essentially the idea with all right, sorry, let me okay, just in a bit. Okay. All right. So just try to picture this. You're in a really remote village. You don't have electricity and you can't afford solar, but you have poultry. You're driving to a really far place. So this is a design brief essentially. You're driving to a really far area using your bicycle to get feed for your chicken. Um, Also to get the chicks essentially to brood. And you also don't have markets for that, and you also don't have money to now get the solar to provide that. So that's the design brief. So the development of this, just in a bit, trying to open the yeah, the model is heavy. Hello. Hello.
Hello, yeah.
Oh,
Can't hear you still.
hello.
Oh, I can hear you now. Okay.
All right, all right. So essentially, what we developed is a poultry facility that can be able to solve all the challenges that they have. The model has loaded. Sorry, was a bit heavy. So this is the concept I developed, took about 3 weeks. So this concept essentially what, I don't know if you're able to see it.
Yeah, I can see it very, very clearly.
Or my screen is still sharing.
Yeah.
Just seeing that. Okay, good. So essentially, what now we what I developed now is a concept to visualize all the challenges that they had and what we could be able to uh, solve with now the facility. So you usually have for areas that require relief. W Jetson is really good at coming up with halls and tents. So these are usually um, these are usually tent-like structures, such kind. Essentially, I don't know if you're able to see this. So such kind, so whole structures. So we decided we are already good at this. So why don't we develop a poultry facility out of this? Taking into consideration regulations, maybe heat, temperatures, what kinds of temperatures do chicks need, in case you're doing slaughtering and such kinds of things. So design considerations, essentially from the brief. So SketchUp was able to give me the platform to really quickly put this into perspective, the solution. So right here, if you're able to see, this is the first phase. Just hide this. So this is the first phase whereby you find that the chicks, they're being brought in for slaughtering. So everything all the way to now, such kinds of things, corns, slaughtering corns, all the way to drainage. I don't know if this is clear, but all the way to drainage, all the way to a centralized drainage system. So something that can be able to show them essentially if we're going to do maybe a slaughtering facility, these are the components that are going to come. If we want to fabricate this, we can be able to do a design like this. Chicks are put right there, inverted. If the places where we're installing the Islamic, that means we need somebody. So we can't do a machine right here. We need somebody to do cuts, physical cuts, kosher cutters. So essentially such kinds of design considerations. And then now develop now a facility that can show what we are trying to give them. And all this powered by solar or renewable energy. So this is completely off grid. And then now try to see the machines that will be going inside here, develop a BOM, and then see the electrical specifications, see the hole size. For instance, this was a 24 by 10 hole size meters. So see how many panels are going to fit. So essentially each panel is going to be what size, do that size, and then see how many panels are going to fit. The electrical team gets these details. They're able to calculate the PV sizing for that. So you see, like, for you to develop such a complex maybe structure, you'd need to conceptualize it, because even for the electrical team to understand the amount of PV, the amount of machines that are going inside, the kind of electrical specifications, drainage, and such kinds of things, it's really good. Even people, movement, lighting, it's really good to do a CAD design, because essentially now from the design brief, we are a way step ahead, because now we know that that this is the requirements and this is how we can be able to do. Now from standards, you can be able to know if doing a slaughterhouse, at the same time doing a cold room to store the slaughtered parts is going to be is something that they're going to is something that meets the standards. Or do you need to do maybe separations? Can chicks survive at the same place where the infection control? How do you handle such kinds of things? So from the design considerations, from the design concept, you can be able to get such kinds of advice from an expertise, and then now further improve the design. So this was the slaughtering area. So in case farmers wanted to do slaughter, they just brought their hens in crates, these crates. The slaughter will be done. Then this will be stored at a cold room. We already have cold rooms as a solution. So after they're stored at cold rooms, they can be packaged. I've removed all the separations, the wallings, that you can be able to clearly see. Don't want to go inside. So packaging, and then now you have a central office that will essentially oversee the entire process. People like a quality control manager would be able to know in case there is infection. Then you'd have a platform for the electrical channeling. So all the cables, everything you need to understand probably from the PV, how are you going to relate in case you're doing controls, temperature controls, in case you want to do SCADA, you can do a concept right there. Where is it going to be? So essentially just visualizing this in case they want to produce their own feed. So a facility that can be able to give them all these solutions and bring different poultry farmers from the village together so that they can form things like chamas, and from there improve their economic sustainability and improve their economic capability to actualize projects like this. And things like you had KFC saying that potatoes are not kept in standards in the standard in Kenya, that they import potatoes outside Kenya because they're not standardized. So things like those, with such a facility, you can be able to actuate now standards to ensure that everything is according to standard. And with that, you can be able to import. You can do now maybe a software application. So essentially, what I'm showing you is with a design concept, you show it to now the client. You can have a sit down, and then you can discuss one-on-one, like, let's do a mobile application to essentially manage this. When I'm not around there, I can be able to see the temperatures for the different rooms and be able to see if anything is going wrong. Let's do maybe an application that can be able to link us to the end customers. And then now you you have essentially an economic improver. If you set up something like this, it will now spur up economic improvement for a really remote village. So just this is just a design concept on how you can be able to develop that. So essentially starts with maybe a single line diagram or maybe a floor plan, whereby you say like we're going to have this at these locations. Which hall are we going to do? How is going to be the movements? How are we going to do the drainages? Do we maybe, you see, with the concept, you find somebody saying, let's try to maybe find a better use of the drainage systems, maybe reuse the water, do a water treatment septic tank at this point, and such kinds of things. So iterating with now the end user. and also with the team. So that was now my very first project. With SketchUp, it was really simple to do. Maybe other advantages that I can state on SketchUp are when you're, for instance, if you're looking into going into renewable energy sector, you're being told, we want to install these panels for this house, but we have trees, but we don't know if we put these panels here, those trees will result in shading on the panels and result in PV losses because of shading. So can we simulate that in software? You have SketchUp, draw the house how it is, maybe do a lollipop tree or import a lollipop or import uh, an asset model of a tree that looks similar to the tree that you have, then simulate the sun using the software. It's really easy and really quick to do. So SketchUp is a free form design kind of software. So just to quickly just show you some of the capabilities. For instance, say I wanted to say in PV, say they wanted to do an installation, renewable energy, maybe they want to do panels in a house, in a square, or they wanted to visualize the house. So they take a picture of the house. Let me just go right here. They take a picture of the house. They show you the picture of the house. They have the dimensions of the house, but they don't know how many panels are going to fit on the roof of the house. And the client also, before he makes, the client has maybe, now say you're good in design, you want to help sales. The client wants to see an edge on top of just the solution that you're providing. So he wants to see the actual end product. So you say, give me the design. Let me see how the picture of the house looks like. Then you just start designing the house, how it looks like. You say like, there's a house, there's maybe, you can do dimensions, but the good thing about freeform is that it's more like just up, drag, and such kinds of things. It's push, drag. If you're good at Illustrator, it's more like, if you're good at SolidWorks, it's more like extrude and pull. It's really easy to use for doing really quick concepts. So you find that maybe they wanted to do certain kind of roof, but you can say like, this is the house base. Now I want to do the roof. You can say, I want to push this up. See, now we have something, we have a roof there. Maybe you can say, they wanted a door right here, a window maybe. I don't know how the house looks like. Then you can essentially just start developing the model. And you see, like, it hasn't even taken 5 seconds. In SolidWorks, if you probably do a concept, just something that is needed quick for a visual concept like the poultry facility. Essentially, if you do it in SolidWorks, it's going to take forever. So to see like can even say the client just in a bit. Maybe you want to see the perspective of the person and the device maybe you're creating or the concept that you're doing. And then now from here you can essentially just quickly develop the prototype. You can bring in solar panels and then you can line them up. Maybe just saying now from the poultry facility, just going out. I can say let me take the solar panels, everything to the brackets. Maybe let's say project management wants to, okay. I've opened too many things. Yeah, not gonna work. Let me close down SolidWorks. Okay. Yeah, that's not gonna work. Okay, so let me just pull it from. You also find that SketchUp has also open source. It has a platform like 3D Warehouse where you can pick maybe solar panel, where you can pick things like solar panels and then now use that. Um, yeah, and then I'll pick that. Okay, let me just sketch a solar panel really quick. Maybe I don't have to, I won't do the graphics for that, but just really quick because it's something really easy to do and it comes really handy when you're doing really quick prototyping. So people want to see the concept really quickly. You can panel. Okay. I can say I just you don't have to. Yeah. Yes. So now move this. I want it to be on the roof. Maybe I want it to be on this side. Do rotate. Um, do move. Put it on this side. Wow, that's a big solar panel. Okay, so you can be able to size this up. You can be able to do dimensions for that. But it's not, it's if you're getting into product design and you essentially need to like just quickly visualize things, you can quickly do that. So say that I wanted to um, show how many panels they're going to be in the roof: x3, x7, x8. Yeah, so you see, essentially uh, you can be able to really quickly represent that. And then now, when you're doing now a representation to the client, it's going to be like, but I don't want you to do a panel right here because I'm going to install DSTV right here. So you can actually show the client that this is the model, and then now from this, now you can start generating drawings. Other things that are useful on SketchUp is maybe you're doing maybe inverter hat structures. So you're in a renewable energy company, they've done installations and then now they want to know where they can put their inverters. These are things that control the batteries in layman. So for the inverters, you have the batteries, you know where the wiring is going, and then now you want to locally fabricate this. Go to the artisans and tell them like I need maybe I need steel tubings, maybe I need squares right here, and then now this is where you're going to do the welding and such kinds of things. And this is the amount of material that's going to cause. If you want to do a slab down there, you can be able to do that. And then now you of course specify the dimensions and such kinds of things. So this one you can be able to create very quickly with SketchUp. So for instance, this is an actual project that we did. So this was useful in doing things like drawings. Just opening this layout just in a bit. So essentially something like this, the client tells you that we need to do ground mount structures at this point, and then now this is engineering drawing, diving you into the advantages of being a product designer. So you can be able to also help project management. So in case they need to do SLDs, you can be able to easily maneuver through this. So for instance, this was Illustrator in combination now with SketchUp. And so just to get the job done, the requirements drive you to the software that you probably want to do. So for instance, this was an installation for this was ground mount structures to hold up the PV panels. So it's essentially how the structure is going to look. This is designed in SketchUp. And then now the panels, how many panels per is it going to take? And then now the inverter structure, how many are they going to be and how it's going to look like, a render of that. And then now the PV layout, where it's going to be, is it going to face north, how the PV are going to be laid out on the client site, and such kinds of things. Even on the roof, you can be able to see on the roof how it's going to be. You can even show where you want to place the inverter and such kinds of things. So yes, so that that is one of the added advantages of SketchUp, that you can be able to do designs really quickly and implement them, and you can actually be able to maneuver around it. But essentially what drives you to the kind of design software is the is the challenge that you are currently facing. For instance, after this, one of the other projects that I've dived into is just quality concept. One of the other projects I've dived into is a power box design. So, say you're on the go and you need a lot of power on the go, and you probably need that means you need like super big batteries, and you need an inverter right there to do conversion. You need maybe an AC outlet, and um, you probably need MCBs, or you need AC breakers and such kinds of things. So one of the things that I developed, this is using SolidWorks sheet metal design. So essentially is now a solution that you can be able to not just yeah, just in a bit. All right, let's play it like that. Okay, so essentially a solution that you can be able to put in sort of like the way you usually do with tokens, a pay-go system. With a pay-go system, dial in the amount of credits you want to use, and then now the batteries allow you to use that, and then now you have the outlets whereby you can, maybe you have an event, you need large amounts of power in a really remote area, you can go with this, and then now power the entire facility. So, and then now you can bring it back home and then charge it with renewable energy. So the design, the sheet metal design, is to house now all the components, the batteries, the battery racks, maybe have caster wheels to move it around, and then now show the concept, how each component, inverter, maybe the pay-go system, the breakers, all the way to the outlets. In case somebody wants sockets or extensions right there, you can do that. And then now inverter, battery racks to hold the batteries, all the way to cabling. So this is in SolidWorks, because now this is on now fabrication side, because the solution This is not conceptual. It's you've already gotten clearly what the client wants, and then now you want to develop now the product. So you can quickly jump into SolidWorks and do sheet metal design for this. So those are some of the things that really drive the product design process and how you navigate through the process. So you remember this concept that I showed you in SketchUp? So this is now the actual fabrications of the different concepts working with a local artisan. So you can be able to see that it has already come to life, and the design made it so much easier. Even the guy who was doing the weldings and everything just quickly did that because they have the design already. They know how it's going to be and such kinds of things. So with this, with design, you can be able to quickly create things. So some of the drawings that essentially that I've been able to do, I've been able to uh, assist people in sales, assist people in project management, all the way to now product development, develop products from zero to end. Now just being driven towards the design software that is required for the particular project that I'm doing. So, for instance, these are some of the installations that we've done based on the designs that we've been able to do, all the way to trainings. I told you, for a product designer, and if you are in product development, not just product design, you're going to have to do trainings. You're going to have to master the product that you're developing, understand the challenges, and then now present that to now the essentially the end user, and then now get feedback, and then see how it's going to perform, and all that. So those are the basics, and it's very critical that you understand the basics, that the client is always the one who drives the design and not the software, and not yes. So this, what you're seeing right here, is also another concept that we've designed and developed. So this is for powering a cooling unit on the move. So what you're seeing here is now the design, essentially, in SolidWorks. And then now this is the concept, how it's going to be, how the batteries are going to be, the inverters. So essentially the power box, the outlets to power the cooling unit, and then now comments on how we can make it better, all the way to now fabrication. So another thing, as a product designer, you also need to know fabrication. You can't stay and just do the design. You need to know welding. You need to maybe have a hands-on. If you've maybe volunteered into projects and you're jumping into product design, I'd probably advise you just have maybe hands-on. You can maybe tell the guys who are fabricating, like, I want to do a weld at this point, at this joint, or you can go to the mechanical team and get such kinds of skills. Some of the skills I got from this is through volunteering. Um, all the way back when I started at Gertrude's Children's Hospital, when lecturers were on strike, went there, told them I want to do maybe internship. Did actually about 9 months on Gertrude's Children's Hospital, just on internship, taking advantage of lecturer strikes. And I learned a lot, from all the way from the basic stuff, repairing toilets, all the way to painting, different kinds of paints, powder coating, all the way to welding, all the way to how to use the tools, the individual tools, to the electrical safety, to the medical equipment, maybe ventilators, to do PPMs and such kinds of things for biomedical engineers. So this kind of volunteering gives you the skills, And when you are in your field, you realize like, this gives me an added advantage because I've already done the design. I'm going now to the fabrication phase. And then I need to know how every device, how every maybe panel is coming together, how I need to maybe ensure polishing is done, it's accurate, how you speak to them. You understand also their challenges. For instance, you know that if you're working with maybe 3mm, if maybe you're working with 3mm mild steel gauge, so you realize like it's very hard for them to bend this. And in Kenya, these machines are not right there. If you're doing an organic design, maybe a circular design, you need to know, hey, these guys who are going to fabricate this, they don't have the machines to bend metal to be circular. You need maybe to do injection molding, or you need to do laser sintering and such kinds of technologies which are not currently locally available. So you need to also involve yourself in the fabrication process so that you have a deeper understanding before you start now designing. So this was now the end product, not the end product, but before now the powder coating and all that, whereby I'd look at the edges, the finishing, try to see how we're going to mount this on the trailer, try to see how the bolts are going to come, even think about the things that people don't see, like this is going to be on a trailer, it's going to be vibrating, and the screws will unscrew themselves. So you need to ensure self-locking screws or such kinds of things, and probably present this to the end user and try to understand if this is going to solve their end challenge. So this is an MVP essentially, and now do tests, see if everything fits and such kind of things before you now finalize on that. All right, so I think we have 30 more minutes. So what I wanted to do essentially today is give you an overview of what what it is like to be a product designer and how you'd want to navigate the field, how you'd probably want to go. So one of the key advantages about product design is that it really drives you towards, it really opens a lot of paths for you, and it gives you an edge. Um, in every engineering company or organization, there's gonna be SLDs, there's going to be single line diagrams, there's going to be a requirement for concepts. Even people who are selling ready-made products, and they're just locally redistributing, there's going to be requirements for trainings. Even in hospitals, you're going to need to do trainings and such kinds of things. So design from the very first, basically the very first platforms that people usually ignore, like PowerPoints, Word, and the Microsoft Office packages, all the way to the 2D design softwares, Inkscape, the likes of Adobe Illustrator, in the platforms of UI UX, Figma, and the likes. These softwares, having knowledge of these softwares really gives you an edge. So one of the key things about a product designer is that you, essentially your products need to first of all solve the challenge, but they also need to look good. So that means everything from your PowerPoints all the way um, to your PDF, uh, to your reports, they need to look good. So that means, let me just try to show you, for instance, for instance, for this solution, this is when interacting with the end user, no, interacting with the fabricators. So to document this, you have to do a report. So you have to ensure even the report looks good. So all the way to, you see, you have to do a report and document all the processes. So for instance, this is this is a report of now the fabrication progress and changes that we've agreed, send it back to the manufacturer and such kinds of things, which are essential. Documenting is usually very important. So apart from this, I think let me just give it back to you so that you can drive me in the last 30 minutes towards what you are really interested in knowing, and the focus.
Well, thank you very much, Steve.
Yes.
That is
And
really
then now,
fascinating. I
yes.
see you've done so many good things. I see we have a question from Sam Kirago. He says, thanks, Steve, for all. Was product design your line of specialization?
All right. So product design wasn't my line of specialization, but I've always been attracted to product design. My background is biomedical engineering. I've always been attracted towards impact, creating impact, and developing innovative solutions for creating impact. So this, I started with diving into the innovation side, realized in most of the innovation projects that I was volunteering for in Makerspace, in Fab Labs, I realized that, such as this, what you're seeing on the screen, I realized that a lot of people don't like to dive into design. And it's very hard when you're brainstorming to come up with an actual solution without seeing it. It's very hard for you to interact with the teammates without them seeing the idea. And I started way back in product design. I started way back in high school. I started with doing PowerPoints for the Science Congress, Nationals, PowerPoints for the team. I was just really curious about design, making things look good. So that has driven me towards now innovation. And then now in innovation, I've decided, in innovation to focus now on design and design engineering, because essentially you can, when you program, it's very hard for you to see to see the end result. Somebody can work on it for an entire month and you don't see the results. But when you're doing design, in 2 days time you actually see the design, and then it's very easy for you to change. So I think that also drove me towards design. And uh, most of the projects I participated, I was driven essentially to design. So, and I've always found it an interesting space because it opens up doors. You even find people in sales saying, why don't you leave the engineering team and come to sales? Because we could really use your help in convincing customers to buy our products because you make it look really good, and the engineering teams and such kind. So you find spaces. I've even interacted with people in sales, people who technical, they're good in technical, but they're good in sales, but they have an added advantage in in knowing design from the basics of understanding color theories, how to mix colors, all the way to fonts and just design theory, just the basics of design theory. They create really good PowerPoints, really good presentations, and that really gives the customer really loves it when they see really good stuff. And I think we can see even it's even key for very large companies like like Tesla and the likes Apple, that they need to ensure that the design not just works for the end user but looks really good. So yes, back to you.
Well, thank you. I think Winnie had raised her hand, sorry. I'll request her to... Winnie, can you...
Thank you so much for the presentation. My question is, you've really explained how we do it for things that are maybe, let's say, outside the human body. I'm picturing a case where I'm designing something that will be implanted. Let's say I'm coming up with,
Yes,
implant basically. Do I
yes,
really
yes,
have to go through all those processes where I have to do product testing? Because like I really wanted to
yes,
see how you link this up with the human body, because now most of us here are biomedical engineers, and there is a unit probably fourth year, fifth year biomechanics, and
yes.
how do you get to do all these things now, like considering the human body and coming up with design implants and stuff like that? Please take us through that process.
Yes, yes. So that's really, really, yes. That's a good question. So I don't know if you're able to see my screen. So
Yeah, we can see the screen.
so in terms of prosthesis, so one of the things that I've been able to design in the past was complete custom jaw replacement prosthesis. So this is, I can say this is what helped me learn SolidWorks and really understand how SolidWorks works, because it was really a headache just doing this design. So the first thing that I essentially did in prosthetics is, first of all, you start with the very first process, that is talking to the end user or the use case analysis. So right here, you can also include research into that. So you can go into people who need this. That is if you have clients. But if you're working on an entirely new development and you're doing now R&D for that, you essentially throw yourself to the end user, because the most important driver for design is the end user. So, for instance, in this custom jaw replacement, I used myself as the driver of the development of this. So I started with imagining how I chew, which kind of forces, how essentially biomechanics, how the biomechanics of the jaw are, and trying to understand the different kinds of forces, how the joints come hand in hand, which are the points that are more likely to break, and what kind of prosthetics would I be interested in doing. I think this jaw was, the prosthesis was inspired by the first, I think, custom jaw replacement back in 2018. done in South Africa. So just motivated me to jump into this, and also biomechanics. So just looking at the forces after understanding now the basics of chewing and how the user would use this, I started now trying to do measurements of my jaw, understand what are the standards associated with measuring a jaw, understand how a doctor usually does a jaw replacement, and essentially the just research and understand essentially the entire process of how the jaw functions, what makes it break, where are the weak points, all the way to understanding now how the doctor may do a replacement for the for the prosthesis, and everything to the forces. And then now after you've done now the research, and then now you start with ideating. So I haven't included them here, but I did very random sketches. I know Engineer Nzomo, if he saw those sketches, he will really make me redo them, because he used to make me do R's and make sure my letters are written very well, because I'm not really good at hands-on sketches and handwriting and such kinds of things. But in software, I'm good. So I did really wireframe sketches of what I imagine would be there and how it would function. And then now from there started now um, working through now the process. So the first phase, uh, the first design, so I jumped into SolidWorks, did this. This was the first design, my first ever design in SolidWorks. I did this, did it like 5 times, doing I did this like, if you know SolidWorks, I did about 70 layers, just this, trying to do things like extrude cut to try and carve the shape that I wanted, essentially to try and replicate the shape of the the jaw replacement. So after that, I saw like this is not working out. Even this, you can even try to imagine if this is making a rotation, it will cause more harm to the body tissue. So I tried to make it smoother, tried to do this, started learning about planes. It was hectic, very many errors. And then now I decided to learn about surface modeling. I think I did the toothbrush sketch and mouse sketch in SolidWorks. So I learned about doing smooth surfaces around SolidWorks. The reason why I chose SolidWorks as a platform is because for prosthesis, you'd need to do an analysis eventually, forces analysis and such kinds of things, stress, see points of weaknesses, because it's a moving structure essentially. So you can do other softwares and then try to replicate the model, but SolidWorks has an all-in-one platform to do that. So after doing several designs, I ended up replicating the jaw, how the jaw looks like, the human jaw, to this. And I designed this based on my measurements, my jaw measurements. So after designing this, I now designed this, which is now the jaw prosthesis. So some of the design considerations that I was thinking around is, how will this be integratable? Jaw, don't have the PowerPoint for that. I had some design considerations. Maybe you can ask me to send it later. But some of the design considerations were, how is this going to eventually merge with the body tissue? Or is it just going to be something that's going to work hand in hand with the body tissue? Because I wanted body tissue to grow around it. how am I going to reduce the weight of this so that somebody who's being who's getting the prosthesis does not have too much weight on their jaw, and it's as comfortable as possible. How am I going to make it very easy to 3D print, polish, make the edges very smooth? Because you see, like, if you're doing a prosthesis like this, somebody's gonna get hurt when they're there's too many sharp edges and all that. So how am I going to smoothen it and such kinds of things? And how is the teeth going to be done? How is it going to fit into the bone? And such kinds of things. For instance, you see, like the front place, I did some grooves so that in case tissue is growing, it grows around inside the prosthesis. It grows inside the prosthesis itself. In case nerves are reestablishing themselves, the channels, they do that around these spacings. I also did this to reduce the spacings, to reduce the size or the weight of the prosthetic. So after now I've done the concept, seen like, this can work. Then now I go to 3D, no, not 3D printing first. First I do an analysis. So these are forces. So essentially this is now concept testing. So I remember I'd mentioned concept testing. So this is also very important that you do it on software. For prosthesis, usually motion. So for instance, at this point, I was doing stress analysis because you know the jaw is going to move from this point. This is where the anchorage is going to be, and the jaw is essentially moving up and down. This is the lower jaw. It's not going to move up and down, but somebody is going to take a bite towards the downside, and they're going to encounter forces mostly from the upside section, a bit from the sideways sections. So in SolidWorks you can be able to put the forces and specify the bite forces. For instance, I did specify the bite forces to the material that I was using for this. And then now with that analysis, you now get the stresses. So in stress analysis, I was able to see that there's going to be a lot of stress at these points. So I needed to strengthen these points. So for the first models, it was completely red, but I needed to strengthen it. And this is how I eventually ended up designing it. Displacement analysis, if somebody is going to chew it with sudden force, how is it going to bend suddenly? So right here you can see an animation that there's going to be a lot of displacement right here because of the forces. There's not going to be displacements right here, but there's going to be a lot of stress. And deformation, you can see how it will deform over time. Strain analysis, where is it most likely to encounter stress? Then now you strain, and then now you strengthen that area so that it does not stretch. So after doing, so after doing now CAD simulation with the maximum bite force scenario, and assessing the weak points, bending and motion range, I was able to now do adjustments and then now do measurements. Now essentially just size it up. This is usually the standard way of doing now the prosthesis lower jaw measurements. So essentially know the sizing of this, and then now from these dimensions, I can be able to adjust the size to anybody who needs their custom. So the doctor just measures, sends me maybe an order, and then now I do. So essentially just thinking around the end product and doing now a BOM. And then material, I think for material, I used titanium because of the bio sensitivity. So I think for materials, you also need to be very critical in understanding. For instance, for the ventilator project, we opted to use perspex or acrylic because it's easier to clean, easier to sanitize, and it also does not, it's not cancerous, and it's also does not cause injury to the end users. It also does not rust and bring such kinds of complications. It's essentially a medical material we decided to use. So you need to also look into the material and everything that's going into the design, and then now do the costings, and then now eventually do a 3D print of. So this is the 3D print that I did of that. Tried to squeeze my jaw in, but I realized that the 3D print was bigger. It's like I had scaled it up or something happened. So essentially to see and visualize it. And then now the next stage from this was to go and talk to a doctor who does now the prosthesis, and then now back and forth and try to understand what challenges might I need to solve with this. But essentially the client usually drives you. So at this position, I had put myself as the patient who needs the prosthesis and then driven the design towards that. So it's true, but testing is very important, and the client is also very important in knowing, in driving you towards the design process. So back to you.
Thank you very much, Steve. Another question maybe that I will have is, which platform did you use to learn about all this? Like, let's say to learn about design in SolidWorks, in SketchUp. Is there like a specific platform that you used?
Yes, there's a platform I used. So I'm a big fan of LinkedIn Learning. Big fan of LinkedIn Learning. I'm also a super huge fan of YouTube. Super huge fan of YouTube. YouTube usually, as long as you know what you want to achieve, there's somebody in YouTube who's gonna tell you how you're going to achieve that. So uh, YouTube really helped me a lot in terms of learning how to navigate through the softwares. It still does, because say tomorrow I get a design, maybe I get a product that I need to develop or do a design, or maybe do a simulation. Maybe somebody wants to do a fluid simulation. Maybe we are developing a vehicle, somebody wants to do a simulation of the fuel, and then now I need to simulate that. So I need to jump into motion, fluid motion animation, and such kinds of things, and analysis. So if I jump into a new software that can be able to enable me to do that and understand it, the first thing that I usually do is, first of all, jump into YouTube, go into the experts, do a bit of reading into the softwares, and then now try to see which software will enable me to do what I need to do. And then now learn the software, learn the software until I feel like I'm able to get results, and not results that are blanket results, but results that are workable and accurate. Like, learn the software almost to expert level in terms of what I need to do. You see, the thing is, software, if you say, even in programming, if you say you want to learn Adobe, let's say Adobe Illustrator, you want to learn Adobe Illustrator, you want to do maybe flyers, maybe you want to improve your PowerPoints, maybe you want to render architectural drawings, or you want to render your drawing in, you want to put this jaw in a human uh, mouth or skeleton and actually show a really good render. So if you say you want to specialize on that, you will dive into the software, you can dive, say in SolidWorks, you can dive into SolidWorks for an entire 10 years and you still wouldn't have fully mastered the software for an entire 10 years. But if you have an idea and you really want to implement that idea, you don't want to learn the software, but you really want to implement that idea, that will drive you to learning the critical things that you need to actualize that idea. And the good thing is, once you learn one software, maybe for instance, my first was SolidWorks, it's very easy for me to navigate into SketchUp, Revit. It's very easy for me to jump, and because I understand the metrics of this, just like gaming and programming, it's very easy for you to jump from one programming language to another programming language. But essentially, what drives it is the challenge. Where you can learn is driven also by the challenge. Say you need to do freeform design, you need to do maybe a panel design, maybe you need to do a cup design. Just go into see somebody who has done that perfectly, try to replicate it, following his instructions, and then you just get shocked, like, you can do this feature with this feature. That really helps you to learn a lot of features and gives you the capability to learn the softwares. But if you're like, SolidWorks is hard, I don't know, I want to learn it from zero, you just start learning it from a book. That wasn't really my learning style. But I don't know. Maybe there are people who learn it from zero. That this is where toolbars are. This is where, maybe, but that wasn't my style. My style was diving into what I need to design and learning on the way, making mistakes. For instance, the jaw, I had to design it almost 50 times. I can remember, like, I did like 50 times. I did the jaw design for almost a month, back and forth, designing the entire jaw and then now scrapping it, like, look at this design, and then now learning, there was this feature, and then now at the end of it, I could be able to do a jaw design in maybe 1 hour or 2 hours. I could do the same design in 1 hour or 2 hours. But learning this design took a lot of designs scrapped out, but I eventually got the hangover of SolidWorks. Yeah. Yes. So
Thank you
back
very
to you.
much. I see there's a question on what is alpha testing protocol from Wendy.
Alpha testing protocol, usually when you haven't pushed the product um, to the end user, before you haven't pushed it to the end user. The end user, you've developed this, you haven't pushed it to the end user, and you're testing it. That's alpha testing. That's the very first stage. Alpha testing is within your premises, within your, so you're doing those tests. You see, like when vehicles usually put dummies and then they send them and crash them and try to see how the forces are affecting, those are alpha tests. Now beta tests are when you've given the user to drive around the vehicle, and then now you see, this is how it's performing, this is how it's going to perform, and then now you get the, essentially doing a pilot with the end user. Yes. Testing protocols are you creating an imaginary situation that you can actualize in lab that represents the actual situation in field, and testing it with those conditions. Yes.
Thank you very much, Steve. It's been a very insightful session. I don't know, is there anyone else with a question? Anyone with a question? Yeah, I think you'll share with us some of the works that you've done so that we can go through, and maybe it's going to trigger some of our audience to engage more. Also, you can even share your handles on LinkedIn or maybe email and
Yes, yes.
contact. Is that okay with you?
Yes, true.
Okay, okay.
It's
Thank you
usually
very much.
very good to learn things. Let me just put it that way. It's very good to learn things. I'm currently, I can't say like I am a master of
Mhm.
product design and development, but I can say that I'm always learning. I'm always learning. For instance, you see, like SketchUp, I just learned it last year when I joined this company. I just quickly learned it from zero. So it's usually good to teach yourself to learn things. Learning, continuous learning is very good. It's very good.
Awesome. Thank you. Thank you very much. At this point, allow me to request our chair, the chair IEEE, Shadrach, to give a comment before we close. I see it's 6 already. A minute. I unmute you, Shadrach. Can you hear me, Shadrach? Shadrach, you can unmute and
Yeah, you guys can hear me?
yeah, we can hear you.
Yes, yes.
Yeah. So that was a very insightful session and I've really enjoyed it. Steve, thank you so much for sharing that. I remember the last time we worked with you in IEEE when you were the webmaster and you were really insightful in many things. One thing I must just comment about is that outside there are there are a few people who are really a master at their own art. And I can say one of those people is Steve, and he has really mastered his own art in design. Something else I must mention is that, you see, when I was in first year, I joined IEEE when I was like, there are so many things to learn. Oh, there is Arduino, there is AutoCAD, there is SolidWorks, there is like a whole lot of things to learn. But one thing you must note is that with time, or what I came to learn later, it's good to expose yourself to many things. And then from there, you now specialize on where you feel like your interest really lies. So that was the main merit, especially on the first year as well on this call, that will really give you a fit. And another thing also is that when I'm working with my colleagues here, one thing I've also learned is by you exposing yourself to what other people do, you get to, okay, when you're doing your thing, then you get to conceptualize what the other team is doing. So it makes you more efficient in some way. Otherwise, I think this was a very, very insightful session. And thank you, Steve, for the good insights you've shared. I also didn't know you can do the design of the jaw using that software. Anyways, thank you. And
Yes.
also just to thank Team EMBS. This has really been a good session. The first one you had last time, an online session, it was also a very insightful one. And just keep it up. Also scale these workshops so that it can give your members, or it can give us an IEEE it can make them feel the weight of their membership. Otherwise, thank you very much, and that was a very good job. Thank you.
All right. Thank you. Just final remarks. So learn. Just if you're a first year, if I'd go back to first year, I just toss myself towards learning different kinds of things, because one of the things that you realize when you jump into the engineering field, you will be you will actually you will get challenges that will speak back to the things that you are failing to throw yourself at. For instance, if you don't like C++, you'll get yourself in a place whereby maybe you're a project manager, maybe you're on the sales team, maybe you're in product development and such kinds of fields. You get yourself in a place whereby you need to give advisory roles in C++ and such kinds of things. You usually get pulled into those kinds of things. If you're an engineer, you always have to keep yourself up to par with what's going around. So if there is another industrial 4.0 technology coming out around, maybe 5.0, just dive into it. If there's Python, dive into it. It also gives you an added advantage. You see, like, for instance, the way that I'm good with design, all the way to PowerPoints, all the way to just 2D design, to logo designs and flyers, things that I used to do in campus for fun. And when I volunteered for IEEE Webmaster, organizing events, trying to get people in, you find that I'm in a place whereby the CEO wants to do an event. He wants to call in people. Nobody in the team can do that, but I did that, so I can do that. I jump in and say, I've done this before. Let me do that. Find somebody, we have a very important presentation to do. And Steve is the best in creating presentations. CEO gives me the PowerPoint that he needs designs. I walk through him and all that. You find that, we need to code this. We're having a problem with maybe doing sizing. We need to do a simple calculator to add it to a web. Somebody knows JavaScript, Python. I can do that. I can do that. Why are we hiring another organization? Then now you can, from those value additions, you can say like, I'm a sales engineer, but I developed an online calculator to size up PV for our clients. So I did extra work. Can you compensate me in somehow? Then you find that, you're getting additional, you're an invaluable resource to the company. So in any place, you're going to get these kinds of things. For instance, right now, a very key hotspot in the market is IoT. Everybody wants to do IoT. You go to a hotel, you go to a bank, we want to monitor our air conditioners, temperatures, we want to monitor, you even go to hospitals. They also want to monitor their air conditioners. They also want to ensure that the server rooms that store the databases for the patients, they want to monitor that. Every single day you find that there is a biomed going to the server rooms, taking recordings with hand that, hey, this day in the morning there was 20 degrees Celsius, in the evening there is 40. And you know Arduino, you can just quickly script something there and then tell them that, hey, I've developed a platform. We can monitor the fuel within our generators. We can even shut down lights if people are going to the toilet, and that will imagine a whole hospital and you're reducing their energy bill. And that will make you a very invaluable resource to wherever you work. So these things, skills are very important. Skills essentially just drive you towards where you need to go. That's why I'm employed in an energy solutions company, and I'm not an electrical engineer. I'm a biomedical engineer, but I'm really good in design. I'm really good in, so you find that it drives you towards where you want to go and gives you that platform if you have the skills. So it's very important to volunteer and get these skills, and it's usually not very hard. We have resources these days. There are too many videos, YouTube videos, too many. I don't know. There is LinkedIn Learning. It's too much. I also prefer Udemy, by the way. Udemy gives me Udemy and Coursera gives me an outline, but because it's paid, I usually use that outline, go back to YouTube, and then try to follow that outline when I'm learning things. But thank you all. I'm very happy that EMBS is progressing on well. I'm proud. I'm very proud. I know Willis is somewhere jumping up. I don't know if Willis is in the call.
He did manage to join the call. I haven't seen him.
Yes, yes. I'm very happy. It's usually very
Okay, thank you very
exciting to
much.
have a network of biomedical engineers which
Yeah,
we can talk to, and yeah,
yeah,
you
we
guys keep
try
up. IEEE
all the
is a very
best
good
and
platform.
thank you.
All right, good day. Just in case you need
Thank you
anything,
for
my
accepting our
LinkedIn profile
call.
is there.
I'll,
Yes.
call upon Steve to give the final vote of thanks so that we can close and give Steve for accepting and creating time and taking time to take us through the product design process. And I know in case of anything, thank you very much, Steve.
Hi. Hopefully everyone can hear
Hi,
me.
hi.
Yeah. Also, just wanted to say a big
Yeah, I can hear
thanks
you.
to Steve for taking the time. The presentation has been quite informative, and yeah, like even personally, I feel very challenged. Because even like recently, I've been trying to teach myself a bit of design, and I'm feeling like the sky is the limit. Thanks to what you have shown us today. Yeah, but also to thank everyone who has been able to attend the meeting today. Thank you so much, guys, for taking the time. And hopefully, we hope that we can have even more. And especially because I know maybe a lot of people who are just digesting and digesting. So as we go on, more and more questions will come up. And hopefully, people, can get answered and we can all grow together. Also to thank all the officials, Shadrach, chairman, even for your words of insight, and to encourage everyone who we want for people to try to take up more places in IEEE and to participate in all the many opportunities which we have. And we can all benefit a lot. Thank you so much. Even you've mentioned, Steve, that you guys and Willis for bringing up the society, and hopefully we can continue to take it further and further. But just a big thank you to everyone for showing up and for everything. Yeah, and wish you all the best and good evening.
Yes, thank you very much, Commander, and thank you very much, Steve. I think at this point we'll break, and I wish everyone a good night, a good evening, wherever you are. Asante sana, Steve. God bless you.